Hello, welcome our topical solution series for IGCSE at Maths 0606. In this video, we are going to do one topic which is on factors and polynomials. The question we have chosen for this video is stipulated that we're going to take one from February-March 2016, paper 1-2. Let's hop on onto the solution, and as we go along, let's enjoy our time together. Here we go. Let's read the questions. It is from question 7. The polynomial fx equals ax cubed plus 7x squared minus 9x plus b is divisible by 2x minus 1. The remainder, when fx is divided by x minus 2, is 5 times the remainder when fx is divided by x plus 1. Well, as you have seen, I have highlighted certain key features that we're going to break it down, translate into our mathematical notations, and go on for our solution. Okay, here we go. The first keywords that we're going to be interested at is divisible. When it is talking about divisible, that means the 2x minus 1 is one of the factor to the polynomial of fx. Divisible. Let me just kind of write it as even it's talking about divisible, it is actually talking about factor. So therefore, we're going to invoke the factor theorem when we're going to do that. And then the next part of the question we might want to interested at is the word remainder. Okay, that will link us to the remainder theorem. Let's go on with the sentence. The remainder when fx is divided by x minus 2. Okay, that's one remainder theorem we're going to form. But here look, it mentioned is 5 times. It is relating to another remainder theorem. And let's go on. The remainder when fx is divided by x plus 1. Therefore, we're going to make two remainder equations, and then we're going to eventually equate them up according to the criteria given to us, that one remainder is actually 5 times the remainder of the other statement. Therefore, let's go on. Now, part 1, show that a equals to 6 and find the value of b. It looks like we are going to ultimately cross our paths with simultaneous equation, because the assignment given to us is to show a equals to 6, which is also means we're going to find the value of a. And let's see the next part of the questions, find the value of b. Isn't that another unknown that you're going to discover? Therefore, yes, certainly at one part we're going to involve solving of simultaneous equation. Let's go on. As the one I highlighted at blue, which is divisible by 2x minus 1, okay, as what I have noted here, the keyword divisible is actually telling us no remainder at the end of the division, and that also invoking factor theorem. Therefore, from the divisor given to us, or the factor, which is 2x minus 1, we are going to draw out the root, which is x equals 1 over 2. And by the factor theorem, we're just going to substitute the x value, which is in this case equals 1 over 2, accordingly into the fx statement, according to the one given to us. Therefore, here we go. F of 1 over 2 equals to, substitute a half of the cube plus 7, the x squared will become 1 over 2 squared minus 9, 1 over 2 plus b. And here we go. This is the key idea about factor theorem. After the substitution with the root, it will equal 0. Then from there onwards, what we do is just simply simplify, rearrange that completed substituted statement into something more simple for us to handle. Okay, here we go. As I recommended here, I multiplied 8 for the reasons that I wanted to get rid of all the fraction. Therefore, why do I multiply with 8? Because 8 is the common factor, is the highest factor that we can use to, when we multiply 8, we actually cancel out all the denominator. Therefore, now we just multiply it as what we mentioned, as just purposely written it down so that it's easier for us to see that. Well, when you're already familiar with this, you actually do not have to write that statement down because you can work out that accurately and correctly. Therefore, by multiplying it onto both sides, we have removed all the denominator. Therefore, we get 8, cancel out the 8, we get A. And here with 4, and cancel out with this 2, 2 times 7, that's how we get 14. And then here 2, cancel out with this 4, so negative 4 multiply 9, that's how we get negative 36 plus 8b equals to 0. Then by further simplifying the like term, you have the positive 14 and negative 36 simplified into negative 22. And I just keep all the A and B on the left hand side and bring the 22 over the other side, which is just getting ready to deal with our solving of the simultaneous equation. And I have equate this equation as equation 1. Then we proceed with the information given to us on the remainder. Therefore, the first dividing of the fx with x minus 2. So we know that we're going to use remainder theorem, and from the divisor x minus 2, we draw out the x value as x equals to 2. Let me make it bigger. Yeah. Okay. So now what we have is that we're just taking the f of x now become f of with 2. Therefore, we substitute all the x with the value of 2. This is what we get. A 2 cubed plus 7 2 squared minus 9 2, and then plus b equals to a remainder. Well, we just use the capital R to represent the remainder after the f of x was divided by x minus 2. Therefore, on further simplifying this, 2 cubed, you get 8. Then 2 squared multiply 7, we get 28. Then negative 9 multiply 2, we get negative 18. And then plus b equals to r, and simplify the like term. There you go, give us the the 8a plus 10 plus b equals to r. But let's just going to keep it there. Now we go on to the next dividing of x plus 1, where you're going to give the remainder. Okay, and here we go. From the divisor x plus 1, we draw out the x value as x minus 1, and then equals to remainder theorem. As of now, I just want to pause for a little while and just to draw your attention from the divisor, each of them given to us. You note that how we draw the x value. Well, just first and foremost, you just assume that this divisor equals to 0, and you draw out the x with you will notice that it's going to be opposite sign all the time. See x, here is minus, so you're going to get positive, here is positive, then you're going to get negative, and then the x value is always, you take this, the divisor, and equate to 0, and that's how we get x equals to 1 over 2. And the same thing we do here, x minus 2 equal to 0, and that's how we get x equals 2. The same thing we have done here. X plus 1 equals to 0, and therefore we get x equals -1. Okay, so that's just to draw your attention. How do we relate the divisor, whether it's the factor, okay, or whether it's just any of the divisor over the polynomial. Okay, now we go on. Now we're going to draw, we have already drawn out the x equals to -1, substitute them accordingly. And as we have done previously, therefore we get -a plus 7 plus 9 plus b equals to another remainder I put in as r prime, okay, just to differentiate the two remainders. And therefore, upon simplification of the whole thing, we get -a plus 16 plus b equals to r prime. Now, what we're going to do is, we're going to abide by the rules given here. Well, the first r is 5 times the second remainder. Therefore, as what I have noted here, the first remainder is equals 5 times of the second remainder. So what we do is, let me just see here, we just take the remainder statement that we have gotten in this portion, put it up here, and equal 5 times of the second remainder, the one that I noted, then with pink, the purple color. Well, there we go. And then let me enlarge this portion. Well, okay, now we have got this accordingly to what the question has given us the information. From here onward, what we just need to do is just simply expanding the brackets, multiplying 5 into each of the 3 terms, and then gather the like terms. As I shown there, I gather the a and b again on the left-hand side and remain a constant on the right-hand side. Well, that's what you have got. Ultimately, we have got 13a minus 4b equals to 7t. And then we are now in kind of wanted to start our solving of the simultaneous equation. Here we go. As we look upon, due to the limitation of the space, that is why I do not write them separately, but I hope that you're still able to find a way through. Okay, here we have just going to solve the first equation and the second equation. Okay, so what I'm going to do is, because we want the first assignment given to us is to show that a equals to b, therefore what I intended to do is I'm going to eliminate b, and then so that we can fulfill our assignment and declare mission done. Okay, so therefore what I've done is, well, we see I'm going to eliminate the b, and therefore for the first equation, the coefficient is positive 8b. This is minus 4. Therefore, I just take the second equation, multiply the 2 with the purpose that we wanted to make the coefficient of b of the same numerical value, which is 8. Okay, once I multiply that, that's why we got from this equation, we got into 26a minus 8b equals 174. Okay, so this is where I write down, okay, the a plus 8b equals to 22 with the third equation. Now I put them side by side, easier for us to see. Let me zoom in. Okay, so now we know that by adding up the equation, we are going to eliminate b altogether, being the first equation having positive 8, the second equation having negative b, right? So negative 8. Therefore, by adding them up, we actually cancel out the two statement of b. Therefore, we get that a plus 26a, that's how given us, 27a, and we add these two together, and then we get 162. And simply dividing 27 both sides, then it gives us 162 dividing 72, and comfortably we compute A equals to 6, and we put in the statement that we have shown, and therefore telling the examiner we have accomplished the first assignment, and therefore we have concluded. Well, to complete the whole question, the second assignment given to us is to find the value of B. Therefore, just taking the A equals to 6 value, substitute it in any other equation that you have got for yourself just now. I have just chosen substitute A equals to 6 into first equation, and therefore A now being substituted with 6 and plus 8B equals 22. Solving this for B, and you comfortably got that as B equals to 2. Therefore, now we have officially completely solving the 2 assignments given to us on part 1, and 4 marks is secured. Now we move on to part 2, section 2. Using the values from part 1, show that fx equals 2x minus 1, multiply another quadratic, the quadratic of cx squared plus dx plus e, where c, d, e are integers to be found. Okay, now what we have got from part 1, we're going to draw it down as I've stated here. From part 1, we have got A equals to 6 and B equals to 2. Therefore, we have gotten for ourselves a complete fx statement with no more unknowns. Therefore, from the given this fx, now we have accomplished for ourselves fx equals 6x cubed plus 7x squared minus 9x plus 2. Now, in order to find the quadratic equation, we know that this is when we multiply this quadratic with this factor, we know that they showed us that it's equals to fx. Therefore, we're going to use the long division to find the other factor, in this case, the quadratic factor. Now, we just go on, lay it down in this long division setup. Okay, take the whole f of x, putting into the dividing notation, with dividing it with 2x minus 1. Then now we multiply. In order to multiply 2 terms, that's why we take up to 2 terms, and we start from here. Okay, so now in order to eliminate 6x cubed, therefore we get this 2x multiply 3x squared in order to give us the results, the product of 6x cubed. By doing this, we can cancel out this. Now multiply negative 1 to 3x squared, we have gotten negative 3x squared. Now minus this, yep, we know that this has been eliminated. Now plus 7 minus 3, we know that it got into positive 3, and that's how we get 10x squared, and pull down the negative 9x, then continue the dividing. Now our target is to eliminate 10x squared, therefore we multiply 2x with positive 5x, and that comfortably we got the same statement, the same term of 10x squared. When we minus that out, we're just going to reduce it to 0. Therefore, now we're going to multiply negative 1 with positive 5x, which given to us negative 5x, and then again we're going to minus this 2, then here we got into 0, and then here minus 9x minus 5x, and that's why it gives us a positive 5x, and that results in negative 4x. And again, you pull down the plus 2 then now we're going to eliminate the whole thing. So negative 2x multiplying negative 2 is going to give us the product of negative 4x. And then we know this can be eliminated into 0. And then multiply negative 1 to negative 2. It gives us the product of positive 2. And again, positive 2 minus positive 2 is going to, the whole thing is reducing into 0. And that gives us a complete division that leaves no remainder. Okay, and that also confirmed the statement given to us previously. It was saying that 2x minus 1 is the factor. And this is also the evidence that 2x minus 1 indeed is the factor of the polynomial. Because after dividing the polynomial, it gives us no remainder. Okay, now we get back to our assignment. Okay, they ask us to find the polynomial of fx, the original format. Now, after dividing, we get for ourselves 2x minus 1, yes, to the multiplying of the quadratic. Okay, so now this is where we have from the long division, this is what we get. Then now you have got the complete arrangement, confirming I've written down there that we have got exactly to what the format that the question requires of us, that is 2x minus 1 bracket cx squared plus dx plus e. And then, yes, we have successfully found it. The value of C is 3. The value of D is 5. The value of E is negative 2. As we put in there accordingly, and that's how easily we obtain the whole value. Now, you have again successfully accomplished section 2. Now you go on to tackle section 3, hence factorize fx completely. Yep, again, with the word hence, that's what we're going to utilize the results that we get from the previous section. In this case, we are taking the result from section 2. Therefore, from here, you draw this statement. Then they ask us to factorize fx completely. Well, as of section 2, you have managed to factorize the cubic expression into a linear factor and a quadratic. Now what you're going to do is you maintain the linear and you're going to factor the quadratic. Yes, with a little help of calculators and or sometimes you can even draw from your experience, either use decomposition method or whatever method that you are familiar with in factorizing quadratic. That is how from this 3x squared plus 5x minus 2, you have break it up into two factors respectively. Then putting all now the three factors, and all of them are in linear form. So in short, you have break down the cubic expression into three linear factors. Congratulations, you have successfully completely factorized fx. And with that, you have concluded your full solution of these questions. So 4 plus 2 plus 2, you have secured for yourself 8 marks. Congratulations. Well, and that also means we come to the end of this video, and I'm looking forward to see you in the next one. And last but not least, again, my favorite wish to you, happy learning always. Bye-bye.